because the duration of our Google Meet is only for 1 hour. Okay, so let's start our class. And our topic for today, so this is a new topic now on industrial building system or IBS. Okay. Actually, this is the last topic that will be covered for this course in this semester. So this is our last class now. Okay. 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 For this topic, we have 5 outlines, which are the introduction to the industrial building system IBS, modular modular coordination, IBS groups, and we will look example of each IBS group, the advantages and disadvantages of IBS, and also the IBS score system. Okay, so these are the outline that we are going to look for today. Okay, okay, this slide, this figure, this is a building system. Okay, so you can see here the building system, they are divided into several subsystems. Okay. And we know that every building, it is an integrated product, meaning that you combine elements, okay, like beam, slab, and so on, to make a building. Okay. So it is integrated element. Okay. And and today our building, they are constructed with a new building system, and we also have different construction techniques compared to long time ago. And this system and technology, they are improving along with the opportunities provided by technology and also industrialization. Okay, so a building, we can view a building as a system. So this system, they consist of subsystem, as I mentioned just now. Okay, subsystem, and each subsystem, they have different function. So from this figure, we can see that there are 4 building subsystem. Okay, number 1, the conventional column beam slab frame system, okay, with timber and plywood formwork. Okay, so conventional column beam slab, I believe all of you know the column, what is column beam slab. Okay, so column beam slab, okay, frame system. But the types of formwork used is timber and plywood. That is the first subsystem. Okay. The second system is the cast in situ. So cast in situ is where you cast your concrete on site. And then for the second subsystem, we use aluminium, steel or aluminium as formwork. Okay, the previous one is we use timber or plywood. And then the third subsystem, this one is prefabricated system. So it is more like a precast panel, concrete precast panel, or we can use the term prefabricated, okay, in general. And then the last one is the composite system. So if you see here, for the cast in situ, they are also divided into table form, bundle form, and for prefabricated system, they are divided into another 3 subsystem, which is the panel system, frame system, and also the block system. So we will look at each of these. Okay, so the first subsystem, this conventional column beam slab frame system. Frame system. This one, as you can see from the picture, okay, so you can identify where is the column. Okay, so this is the column. You can see example the highlighted red, that one is example of column. Sorry, beam. Okay, this one is column, the vertical elements, that one is column. And then the flat area actually here, that is for slab lah. Okay, so the conventional column beam slab frame system, and we see here in this figure, the type of formwork used is timber and plywood lah. Okay, you can see they use timber and plywood. So this is the first system. Okay. Okay, and then another example of conventional column beam slab frame system. So this one they already removed the formwork, the timber and plywood formwork. Okay, so you can see the column, the concrete column, the concrete beam column, and also the. Okay, so that is the first system. Okay, the second one, the cast in situ. The cast in situ here, the formwork they use the steel or aluminium. But actually, the cast in situ system also it can be constructed using timber and plywood system. That one is the first system that we discussed just now. Okay, so the second cast in situ, but using aluminium and steel as formwork. So what is cast in situ? So cast in situ concrete, you can see the second figure. That one is the example of cast in situ concrete. Okay, so sometimes we call it as poured in place. Okay, so this is concreting technique which you do it on site. Okay, that's why they call it cast in situ concrete. So the difference between the cast in situ and precast, if you see the first picture, that one is the precast, like example of precast concrete. Okay, so for precast, it is made at the factory, and you transport it to the site, and then you position at the predetermined place. So that is the difference. Okay, but for second system, we are referring to the second picture, okay? Cast in situ concrete. Okay, so this is another example of in situ concrete, cast in situ, where you mix, you place your concrete, and then you cast your concrete on site. Cast in situ. So this system also you can use to construct your building. Okay, the third subsystem, this one is prefabricated system. Sometimes the popular term we use is precast panel precast concrete. Okay, precast concrete. Okay, so this prefabricated system, it consists of panel system. So if you see the first picture, number one, that one example of panel, precast panel panel system, where the concrete wall they are cast at the factory in the panel form, and then they bring it to site. So that one is a panel system. Okay, the second picture, okay, number two, okay, that one is a block system, example of block system. So this one like brick, but we don't use brick lah, but it's more like a concrete block, okay, which is made on site, and then you bring it to the you make it in the factory, and then you bring it to the site lah. Normally, for a block system, the size of the block, okay, they are larger than the conventional block, okay, because they are following the modular coordination system, okay, under the IBS. Okay, and the third picture, okay, that one is the frame system example of frame system. So the term prefabrication here describe elements that are manufactured under factory conditions. So you must always remember prefabricated system, meaning that the elements, the structural elements, the building elements, they are manufactured under factory condition, and then transport to construction site for you to construct your building or for the civil engineering work. So if you refer to the example here, okay, example, this one, example, the prefabricated units or precast may include doors, okay, stairs, window walls, window panel, floor panel, roof trusses, room size component, and even entire buildings also. Okay, you can prefabricate it at the factory, and then you bring it to the site. Okay. Okay, and the last system, this one is the composite system. Okay, so for composite system, every time you you meet with this term composite, meaning that you're using more than one materials now for your, for example, for your slab, for your beam, and so on. Okay, so it provides a method of more using more than one material, 2 or 3. Okay, so that the materials can be utilized to its best advantage, and that's why they use combination of more than one material. Sometimes when they combine materials more than one type, it will give better performance lah, okay, rather than you use one type of material. Okay, so the new approach is to use the steel concrete composite construction. So as you can see from this example, the composite concrete can be produced from, you see here, okay, this is composite concrete, where it is made from combination of concrete. Okay, the first one, that one is concrete slab. Okay, so combination of concrete, and then they also incorporate the reinforcement, the slab reinforcement or steel rebar. Okay, so there are two materials already, and then they use composite deck beam. Okay, this one, composite deck beam. Okay, and also structural steel beam. Okay, so there are more than two materials are used here. That's why these elements, they can be categorized under composite system. Okay, so the greatest advantage, okay, the greatest advantage of composite material is more to the strength and also stiffness combined with lightness. Normally, you can produce lighter elements lah. Okay, if you use the composite system. Okay, so by choosing suitable combination of steel bar and also matrix material like concrete or different types of materials lah. Okay, so manufacturers, they can produce properties of structural element that can fit requirement lah for a particular purpose. Okay, that's why they use the composite system. Okay, so that are the 4 subsystems that make a building system. Okay, so you can choose any system that you want to use in your construction. Okay, next we go to IBS. So what is IBS? Okay, so this is the introduction of IBS. So it may be defined as a building system. This is a building system, in which the structural component, they are manufactured in the factory, on or off-site, then transported and then assembled into a structure with minimal additional site work. So that is the definition of IBS, meaning that in general, we use the precast lah, precast panel, prefabricated panel, building construction, but using the IBS system. So this is one of the improved building system that have been introduced. One of the reason because we want to achieve faster completion of your project. Okay, but with mass production of building elements, which is produced in the factory lah. So at IBS, when you use IBS system in your construction project, actually it also gives a lot of benefit lah. Okay, for example, okay, you refer this picture. So you see here all the structural elements. Okay, they are already made in the factory. These are the example of the structural element that can be made at the factory. We can categorize it under the IBS system lah. So you can see here, this is the wall panel, the orange color, that one example of wall panel lah. So wall panel also you can make it at the factory. But the dimension you have to be careful lah, because when we talk about IBS, the dimension of the elements, they must following the modular coordination, meaning that is the standardized dimension lah. Okay, for IBS. Okay, so in terms of dimension, that one we will discuss after this. Slab also, the green color here, that is example of the precast slab. Okay, slab panel. They also can be made at the factory, so we can categorize that one as under the IBS lah. Okay, and also you can see beam. So the gray color here, that one is beam. Beam also can be made at the factory as a precast beam panel, and so on lah. You can see the roof, the ceiling, the door, window, and so on. Okay, so these elements will be transported to the site. Okay, then you assemble it to form a unit house, building, and so on. So this is the concept of IBS lah, like Lego. Okay, they provide it in loose elements. Then you buy it and then you combine the Lego elements to form shape you required lah. That is Lego concept. So the IBS actually they are following the Lego concept lah. Okay. Okay. So there are various IBS used throughout the world. There are various types of IBS lah, okay, that are used in throughout the world, and they are classified into three major categories. Okay, the first one is pause and beam system, frame of pause and beam system. So this is the example from the figure, the slide. You can see that is the example of pause and beam system. Okay, meaning that the pause here referring to the column lah. Okay, so the pause and beam system, column and beam system. So column and beam also you can make it under this IBS. Okay. Okay, and then the second one, this is the panel system. Okay, you can see the panel system is, the example here is the wall, precast wall panel, okay, already made at the factory, and then they bring it to site. Okay, then the third system is the box system. So this is example lah. Culvert is also can be considered as a okay, box system. Okay, so using this IBS system, it has been proven successful in some countries such as Finland, Denmark, Netherlands, Singapore. So they use IBS, England, and US. It's actually this IBS keep on developing in also in our country. Okay, how about in Malaysia? Okay, so yes, in Malaysian construction industry also, they encourage us to adopt this IBS system lah. Okay, Malaysian construction industry encourage us to adopt this IBS system. Okay, so but in Malaysia, the IBS they are divided into 5 main groups. This is for Malaysian construction industry lah. IBS they divided into 5 groups lah. Okay, the previous one, if you refer here, they divided into 3. Okay, in general worldwide lah. Okay, pause and beam system, panel system, box system. But in Malaysia, we divide it into 5 main group. The precast concrete framing, panel, and box system. So they combine this number one, they combine the framing, meaning that the post and beam, okay, panel and box system, and also formwork system, okay, steel framing system, prefabricated timber framing system, and block work system. So there are 5 main IBS groups lah in Malaysian construction industry. Okay, okay, the first IBS system that we use in Malaysia for precast concrete framing, panel, and box system. Okay, so the types of structural element for this system, like precast column, beam. Okay, this one precast column, beam, slab, and also the 3D components. That one consider under box lah. Okay, box system. These 3D components like balconies, staircases, toilet, and so on lah, kitchen, okay, and so on. Okay. So this frame system may be defined as the structure that carry loading lah. Normally, when we call structural frame system, meaning that the elements, okay, it is categorized or fall under the structural elements lah, because it carry loading, okay, through beam, column, and finally to the ground lah. Okay? So that one is structural element. Okay, so this system, okay, the precast concrete framing, panel, and box system, it is used in the construction of, for example, like construction of bridges, parking lots. Also, we can use this system. Warehouses, if you have this industrial building, also you can building, sport facility, school, and so on. Okay, we can use this IBS system, precast framing, panel, and box system. Okay, Okay, for formwork system, this is number 2 lah. Okay, the formwork system. So formwork is actually a mall, acuan. Okay, when we talk about formwork, it is actually acuan lah, a mall. Okay, so we use mall to store and haul wet concrete. Okay, because if you're not using precast, you need to cast your concrete in situ lah. So if you want to cast your concrete in situ, meaning that you have to construct formwork first. Okay, so this formwork is used to store and hold your concrete, wet concrete, until your concrete harden. Okay, so after your concrete harden, then you have to demolish. Okay, you remove the formwork. Okay, so the formwork is built using fabricated formwork. So formwork also can be made at the factory using this IBS system lah. Okay, modular coordination using this IBS system. Okay, normally this fabricated formwork, it is with a metal frame. Okay, usually steel and aluminium lah. Okay, this is for formwork system. Okay, so the picture here you can see that is the example of formwork, steel formwork. Okay. Okay, and for steel framing system, so this is number 4. Yeah. Okay, steel framing system. For example, also you can see in the figure, the slide. So here you can see that the horizontal and vertical, okay, elements, they are formed using structural beam and column. So the structural element, it does not compulsory using concrete. You can use steel. Okay, so this is under the steel framing system. So you can use steel beam, you can use steel column, but it depends on your building project, building project. And then another types, they are portal frame, roof trusses also, that one we already discussed, okay, in roof topic. So roof trusses also, they can they can be made at the factory under this IBS system lah. Okay, so all this can be produced using steel material. Okay, so that is number 4, steel framing system. And the next one, okay. Oh, so this one example, okay, example of timber framing system. Okay, so this is the next layer of the steel, is the prefabricated timber framing system. Okay, so structural timbers, they are prefabricated at the factory, okay, because they want to produce timber frame. Okay, on this example of timber frame, which consists of a beam, a column, roof trusses, and so on. So timber also we can use as a framing system. Okay, that is the number 4 system under the IBS. And the last system is the blockwork system. Okay, so blockwork system, this is a construction of concrete blocks. Normally, the size of the concrete block, they are larger than the standard clay brick or concrete brick, okay, because we follow the modular coordination system. Okay, so the concrete masonry unit block, this concrete, as you can see from the picture okay, the concrete masonry unit block, you can use them to build load-bearing wall. So load-bearing wall meaning that the wall will carry loading, and also non-load-bearing also can, okay, and you can construct the wall component. And the types of blockwork system, for example, like the interlocking concrete masonry unit. Okay, lightweight concrete block also can you can use it, cellular block, cement sand block, and so on. So there are actually many types of block that you can make using this IBS system lah. Okay, you can more on the size lah, dimension. Okay. Okay. So this table 4.1, so this is the types of IBS system used in the developer firm in Malaysia. So actually in Malaysia, we already implement this IBS system lah. Okay, but maybe not 100%. Okay, because of some limitation in the construction industry lah, that limited us, a contractor, okay, to use 100% of this IBS. Okay, but this table 4.1, this one is actually based on the questionnaire done by a researcher from UTM lah. They want to study how frequent this IBS system used in Malaysian construction project. So if you see the table, the first column, okay, that one is the type of IBS system lah used in the developer firm. Okay, so we also have score because we want to know the frequency of the IBS use. So under this, the types of IBS, you can see 1, 2, 3, 4, 5. So this here they divided into 6 lah. Okay, 6 IBS system. Okay, the timber framing system. So timber framing system meaning that the structural element, the beam, the column is made of timber. And then steel framing system, the column and beam, this one is made of steel. Precast concrete system, steel formwork system, 1, 2, 3, 4. Okay, number 5, 5 block work system. And the last one, this is more on the standard components lah. Okay, so column number 2, okay, this one is the frequency of the respondent. So they give a score lah, 1 to 5. Okay, so overall, again, column number 5, 4, 3, this is average index, and this the last column, that one is ranking lah. They put ranking or position. So which type of IBS is popular lah, popular use in Malaysian construction. So it can be summarized from this table 1 lah. Okay, that generally all the respondents, they are moderately use all these IBS system types, meaning that all this IBS system actually they already implement in their construction site lah. Okay, so this includes the timber framing, steel framing, precast concrete, and so on until the component. Okay, however, if you see here the position, okay, the most popular IBS system they use is the timber framing system. Okay, followed by steel, then precast concrete system, and the last ranking is the standard components lah, in ranking number 6. Okay, so this is the types of IBS used in Malaysia. But in general, moderately they use all of the IBS system lah in their construction. Okay, why we need IBS? Okay, why we need to adopt IBS in construction? Okay, so to answer this question, we need to understand our scenario lah in construction industry. Yes, when you compare this construction industry, construction sector to other sector, okay, the construction industry suffers from low productivity, safety, and quality control. Okay, so low productivity because when you want to construct a building, you cannot finish it within 1 week. Okay, it depends on your planning, your management, your labor, and so on lah. So low, yeah, okay, it needs time lah. In terms of safety also, okay, so most of safety is very important lah. If you don't care about the safety, this one will cause dangerous lah in your construction. Okay, and then quality control is also very important. Okay, and also due to the traditional labor intensive practice, because when we do construction, we normally will have labor lah, because we don't use robot. Okay, we use labor. Okay, so this we call it traditional labor intensive practice. So because of this labor practice, the 3D syndrome, which are the dirty, difficult, dangerous, has always been associated with the construction industry. So you see the reason here. You can see the reason why we need IBS. Okay. So in other words, the construction industry always be related to messy sites. Okay. Semak. Yes, messy site. High wastage because when you order, let's say you want to order roof, you will not use it exactly 100%. Okay, so if you order the roof, maybe there will be extra roof material, for example. So you can categorize it as wastage lah, because after you complete your building, you will not use that extra roof anymore. So that consider as construction wastage. Okay, labor intensive, okay, low quality, and also delay. Okay, so in general, construction industry, they always related to this 1, 2, 3, 5 items lah. Okay. Messy, wastage, labor, low quality, and delay. Okay. So, what is the benefit? Benefit of adopting IBS? Okay, because we already look at the problem. The problem, okay, in construction site. So we need to adopt the IBS in construction because it will help to reduce the site labor. Okay, reduce the site labor, then you will save cost lah. Okay, and then you also need to reduce wastage. Okay, minimal wastage, because one of the problem in construction is high wastage. So you use IBS, you want to reduce the wastage produced from the construction project. So if you can reduce the wastage, meaning that less material can be found on site. Okay, so this will make the site cleaner, cleaner environment. Okay, and by using IBS also, the quality of the structural element you can control because you're not casting your concrete on site. You order your concrete from factory. So the factory actually they already produce the concrete, the precast concrete under control condition. Okay, and since the element they are produced, we order the concrete elements lah from the factory. Therefore, no more or less construction materials are placed on site lah. Therefore, this will make our site neater and safe. Okay, and in addition, since the structural elements they are produced at the factory and then you transport it to the site, so the project completion will be faster. So why? How can this precast concrete, the IBS system, they can reduce the duration of your project? Because in the conventional construction, usually you need to wait for several days lah after you do concreting. After you do concreting, your concrete is still in wet condition, so you cannot proceed at the next stage lah, next level. So you have to wait maybe up to 7 days before you demol your concrete, because we need a concrete to gain sufficient strength lah before you proceed to the next level, next stage. But by using this IBS system, the curing time, also the 7 days example I say just now, that one is because of we need to cure our concrete to make sure it is hardened lah before you can demol or remove your formwork. So by using this IBS system, the curing time of the structural element actually can be discarded. You can remove that time. Okay, and finally, considering all above reason, the final cost. This one also can be reduced lah. Can be reduced. Okay, so okay, Malaysia has seen more than 40 years lah of IBS planning and implementation. Yeah, although the pace was slow during the late 1960s and 1970s, the momentum was steadily increased and gradually become part of the industry lah. So in the present day, IBS has marked its present by successful projects. So you can see there are many projects actually using this IBS lah. So among significant projects that use IBS, you can see here 2007, 1916. So this is not the updated lah. Nowadays also we have many projects actually using IBS. Okay, so the stormwater management and road tunnel. Okay, that one is smart tunnel. Okay, Kuala Lumpur. Okay, Kuching International Airport, and so on lah. You can see from this list. Okay, so these are some example of construction project using the IBS system. Okay, so this one example of custom immigration and quarantine complex. So this one in Johor Bahru. So this building using precast concrete beam, column, and hollow core slab in the construction lah. Okay, so this one is Open University, formerly known as JPA Kuala Lumpur. So the function of this building now, they use it as campus building. So for this building also, they use the precast concrete beam, column, and hollow core slab. Okay, this one is near to us lah. Project located in Sabah. Project Perumahan Rakyat Telipuk. I believe some of you, if you stay or if you go to the Telipuk area, you can see this building. Okay, so this building is residential building and it uses steel formwork system lah during the construction. Because the steel formwork system they are considered under the IBSS also. Another example, this one is Telekom Malaysia. Okay, using steel structure lah for the Sky Garden. Okay, this is water sport complex. Okay, for this one, the IBS system they use tubular steel decking for their floor system. Okay, and this is apartment for government. Okay, so this is in Putrajaya lah, where the wall was built using the precast concrete panel. Okay, and then airport airport terminal buildings where they use the roof structure. KL Central Station, steel roof structure also, and precast hollow core slab. This one is Serdang Hospital. They use steel beam and column and also precast concrete half slab. Okay. And government school in JB lah. They use beam and column using the precast elements. So this is an example. Okay. So this is another example lah. You can see PKNS. This one in 2022. City Mall 2012. Okay, and so on. You can refer to the lecture notes lah. Okay. Okay, with the advancement of technology and innovation, there are various prefabricated materials that have entered the market. Okay, so this material like gypsum, wood, polymer, fiberglass, glass and aluminium. So they're also based on the IBS system lah. Okay, not only concrete, not only steel. So other material also they're try to make it using this IBS lah. Okay, so this IBS system, I already mentioned this in the previous slide lah. The IBS system, this one is based on the modular coordination MC principle. So this modular coordination or MC, this is actually an international system lah that standardized measurement in building. So here the MC, the modular coordination, they use M. They use the I cannot say it unit lah, but they use M as a basic module. Okay, so 1M equals to 100. So that is IBS system under the modular coordination. Okay, so they standardize the dimension. Okay, so for example, like this in this figure. So this is dimension as space coordination concept lah. So the building and components they are placed at their designation based on the unit or basic module. So you check here the length, the size of this area. They use the modular coordination. So M. Okay, they use the capital M to indicate the modular coordination. So just now I said 1M equal to 100. So 45M meaning that 4.5 meter lah, 4,500 meter. So 9M is 900 millimeter, 3M is 300 millimeter. So they standardize it like this one lah. This is the standard dimension used under the IBS system. We call it as modular coordination. Okay, so what is the disadvantage of using IBS? Even though there are many benefits, okay, of using the IBS system, but there's still disadvantage lah. Okay. Okay, so the disadvantage, okay, the first one, if you want to construct building using this IBS system, the contractor needs to have a high initial capital cost. Okay, so you must have enough money lah. Okay, but this cost might be transferred to the buyer. Okay, and then there are only a handful of IBS player in the country, especially in Sabah. We don't have many IBS manufacturer lah, because of the monopoly system. That is one of the reason. And then standardization of building components and element also will result in a lack of aesthetic value because it is made like standardized size, okay, dimension. So your building tend to be very boxy, okay, which may not look not impressive lah as the conventional curvy building. Okay? Because when you have aesthetic, you want your building to have the aesthetic appearance. Normally, the best system you can use is the conventional method lah. But for IBS, that is one of the disadvantage. And then bad workmanship while using prefabricated panels. The precast panel, the prefabricated panel, actually they are in good quality lah, because they're produced in the factory, yeah, under control condition. But when they send it to site, yeah, your construction site, if your labor um, in terms of the joint is not good, okay, bad workmanship done by your labor. So this can result in problem, especially in the joint, okay, joint between this precast panel. If the joint is not good, then it will cause water leakage. Okay, number 5, this is components. Um, they are considered to be inflexible, meaning that not flexible for you to do renovation lah. Okay, because most people after when they buy the building the house, they want to drill hole for land. That one is okay lah. If you just want to drill, it's okay, you can drill. Okay, but for some they want to hack the wall, for example, to allow for additional conduit work and wiring work. So this one is difficult, because your precast they already made at the factory. So actually, in terms of renovation, this one is one of the disadvantage of the IBS system. Okay, and if let's say you want to buy two adjoining unit, then you will have problem lah to hack down some wall to allow the units to through. That is the disadvantage lah. Okay. Okay, the IBS content scoring system. This one is actually a systematic and structured assessment system that can be used to measure the usage of IBS in a consistent way. So let's say you have a project. You want to measure how many IBS system are used for this project. So you can use this IBS score lah. Okay, you want to measure how many the content of IBS in your building project. Okay, so the IBS score, they emphasize on the following elements, okay, number 1 to number 5. Okay, so they will check whether you use the prefabricated and precast concrete components, whether you use off-site production of component, use of standardized component, repeatability, and design of MC concept. So that are the following the elements lah that is considered in the IBS score. So the calculation of the IBS score, they're based on these three parts, these three main parts. Number 1 is structural system. Okay, for example, are you using the precast concrete beam? So steel framing, prefabricated timber framing, and so on. So if yes, then you can get the maximum score is 50 points for part 1. That is for structural. Okay, structural system, the elements that carry loading lah in your construction or in your project. Part 2 is wall system. So they also evaluate your wall system lah. As the maximum score is 30. So let's say you use precast concrete panel wall or glass, dry, or and so on lah, block work, so that you can get marks from these elements. Okay, 30 points is maximum. And the last part is part 3. This is more to simplified construction solution. So the maximum is 20 points. Example here is like the standard components. You can refer to MS 1064. Whether you use the standardized grease, the 3D prefabricated component like toilets, staircases, and so on. So these 3 elements will be considered in the IBS scoring. Okay, and then so this is the formula. Okay, so the formula, the IBS score equal to score for structural system. This one, number 1, this is part 1, plus score for wall system, plus score for other simplified construction solution. So you will get the IBS score. So the detailed formula, you can refer here lah. QS, the first score for structural system, QS over QST, you times with FS, and total of this, you times it with 50. Same to the rest lah. So you can see what is QS. So here QS is the construction area of the structural system. So you have to do some calculation lah. Okay, QST is the total construction area of the building, and then FS is the IBS factor. So all these FS, FW, and S, this one you can refer to table 1, table 2, table 3 and table 4. That is the factor lah, IBS factor. Okay, it's a simple calculation. Only you need to identify the IBS elements, the elements because I'm a prefabricated element in your construction or building project. Okay, so housing with a minimum IBS score of 50, 50%, minimum 50%, you can get exemption by CIDB from paying levy. Okay, so levy here meaning tax, fine, fee or fine lah. Okay, so you can get exemption. So that is the benefit lah. Okay, if you're using this IBS system. Okay, so that's all for today. Okay, so as I said just now, this is our last lecture. Okay. Okay. Yeah, I want to share your attendance. And don't forget that because your assignment 2 submission is on, I think on 23rd of June. So the submission link, that one already in the ITEL. Hopefully this is the correct link. Okay, so that is our attendance link. So please mark your attendance. Let me double check. Okay, yeah, that is Constech. And next week we're not going to conduct any class, but I need you to do some self revision for our test 2, and test 2 will be conducted in week 14. Okay, week 14. That one is face to face lah. Okay, so that is the last meeting lah, last lecture for this course. Okay. So, do you have any problem with the attendance link? Oh, okay. So, after you mark the attendance, you can leave the Google Meet. Okay, thank you.
Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Yeah. Oh, yeah. Oh, chapter. I will inform you later lah, because I haven't prepared the test, the question test actually. Okay, but our test 1, that is for substructure kan. I can say that for